Hi, hello everyone. Good evening and welcome to the fourth and final session of the Green Chemistry Workshop. Um, so today we're going to be starting the session with a small, with a quiz kind of thing. So you can see two images on the slide before you. So could you identify what is in the what are the images? There? Uh, you don't need to raise your hand. You're the only one. Yeah, you can answer.
It's coal and diesel.
Yeah. Now, and in these, there are three images here as well. Identify these as well. Anyone?
Clue is Elon Musk.
Yeah. Do you wanna could you identify these images as well?
Yeah, the second one shows the Tesla, which is electric car, and the third one shows a solar powered car. The first one
What do
shows,
you
I
think this?
guess, natural fuel, something like that.
Okay. Okay. So now, what do you think is similar between these first two images that are there?
They are non-renewable fuels, and actually they can be harmful to the environment.
And, the second one, these are all
These are
renewable
totally
energy.
opposite.
Yeah. So what?
I'm right. So like, would any so like, how many of you have petrol cars and how many have diesel cars?
Anyone can answer this. How? Yeah.
What
Anyone?
was the question?
I'm asking
So
how many of you guys have petrol cars and how many of you have diesel powered cars?
I have a diesel powered car.
Pankaj, ma'am.
okay, I have petrol powered car.
All right. So, out of the two, petrol and diesel, which one do you think is better for the environment?
I think petrol, because petrol cars have a limit of 15 years in Delhi NCR, while diesel cars have 10-year limit.
So, even though diesel cars, they actually have more, they have lesser greenhouse gas emissions, but they release certain noxious gases and certain particulate matter, which even though they release lesser greenhouse gases, they contribute more to global warming because of certain gases that they release. Um, so now that we know that diesel cars they're bad for the environment and they produce certain emissions which are harmful for the environment, even though there are you know resources such as uh, even though there are electric cars, there is a need for fuel sources like fossil fuels, which are better for the environment and also are sustainable and renewable. So, do you know of any such fuel which is good for the environment and acts like a fossil fuel?
So diesel cars emit more uh, dangerous gases, but they are not greenhouse gases.
They release lesser greenhouse gases, but more of certain like nitrogen based gases, which make them more harmful
Acha.
for the environment and they contribute more to global warming than petroleum and gasoline cars.
Okay.
And also, a few days back, there was this article which came. So, if the AQI in Delhi crosses 450, then diesel cars with BS4 engines will be banned. And this is going to start from October 1st. And this is because, again, they release certain noxious gases and particulate matter, which is bad and makes the AQI poor. So, and now I was asking, so like there's diesel. Do you think there's any other fuel source which is like diesel, but it's better for the environment? It has lesser emissions, and yeah, answer.
What about natural gas?
So, natural gas, Praneel, you want to say?
So like you're talking about CNG, right?
Yeah, CNG, natural gas CNG.
Yes, that is like you mentioned, seeing all the commercial vehicles and all, they mostly have CNG. So yeah, yeah, it is more eco-friendly, but still not to the level at which the pollution can be reduced drastically.
Okay.
Yeah. So the other alternative fuel source that I wanted to talk about was biodiesel, which we'll be talking about in this session. All right. So now that we know, so biodiesel, it's pretty similar to diesel in terms of what it can do, but it's a bit less efficient. We'll learn more about that later. So, first, biodiesel is an alternative fuel which is similar to diesel that we use already, and it can be derived through from vegetable oil, animal fats, and um, wasted vegetable oil, which is used in cooking. And the process of making the vegetable oil into biodiesel is called transesterification. So when we performed the experiment, we used waste vegetable oil to create biodiesel using this process of transesterification. And we'll be talking more about that later. Um, so
Okay, so like right now we learned about what exactly is biodiesel, like it's an alternative to the actual diesel that we use. So now we'll take a look at why we should consider using biodiesel. So we have already spoken about it already. It's much more eco-friendly. So firstly, it removes air quality and reduces greenhouse gas emissions. So like in the previous slide, a few slides before, we saw an article in which diesel, if the AQI is above a certain level, diesel cars will be banned. So like unlike diesel, biodiesel actually improve the air quality instead of polluting it. Secondly, we have our second point is that it's a renewable energy resource, unlike biodiesel, which it, which is a non-renewable energy resource. And lastly, it prevents the wastage of products such as animal fats and oils. So like we are using, like Aditya said right now, we are using waste vegetable oils, like waste oils, like you can even use olive oil, coconut oil, other vegetable oils. Just so you're making the best out of waste. So like it's a process of reusing stuff.
yeah, all right. So after this, so the use of biodiesel, just like diesel, it can be used to power vehicles, and it's an alternative because the other fuels that we spoke about before again, they produce certain harmful emissions, and biodiesel reduces these emissions. Um, and yeah, and it's a greener and more sustainable alternative. So now we'll be looking at the experiment we performed. Like here, we talk about transesterification, and yeah,
I think Adi has a question or he's raised his
yeah.
hand. Do you want-
Yeah, I have a question. Hello.
Go ahead. You can. Yeah.
Yeah, so can we make biodiesel at home only? Because whenever we go to petrol pumps and petrol stations, we never see biodiesel, and only petrol, diesel, and CNG. These three options are available. So can we make
Will we?
biodiesel?
We'll
I
be
will
talking about this later as to why we don't have commercially available, like readily available
Acha.
biodiesel yet. But it's basically because I can tell you a bit right now that biodiesel is basically a bit less efficient and it's also extremely costly to make it. For example,
Oh,
here when we made biodiesel, we used around 200 ml of vegetable oil, but we obtained much lesser biodiesel. So it's going to use a lot of oil and it's much more expensive than already available diesel and petrol. So there has to be more research and everything done. And also, I don't think you would be able to create it at home because we used ethanol and we used NaOH, sodium hydroxide, to create this. And we also
okay.
use certain apparatus such as separating funnels. If you're able to arrange for them, you should be able to make the biodiesel at home. So,
Okay.
Okay, so here first, we mixed NaOH with ethanol to create a solution. And
What
So
did you mix with ethanol?
NaOH, sodium
That's
hydroxide.
sodium hydroxide. Okay.
So basically, in the previous video clip which you saw, we basically dissolved the sodium hydroxide. So we took 1 gram of sodium hydroxide and dissolved it in water. That's what we did. Now that this is the next
Ethanol.
step.
When we were doing this, we directly dissolved it in ethanol.
Sorry. Not ethanol.
And now we're taking, in this case, we used vegetable oil, which is unused, but you can use paste vegetable oil. We just didn't over here. Um, right. Okay. So here we're adding vegetable oil in a beaker, and we heated it at I think 60 degrees for around 6-7 minutes, and we let that heat. Then we added the solution of NaOH and ethanol to the vegetable oil while we were stirring it. After this, we added the solution to a separation funnel, and we had to wait for around 40. We waited for 48 hours before separating. So this is before the biodiesel was separated, and now this is after. This is around after around like 5-6 hours, I think. That we're gonna show. Right.
Yeah.
Sorry. Right.
So in another separating funnel, we had actually done the same thing using coconut oil. So the exact same process is just that we use coconut oil instead of vegetable oil.
All right. In this image, you can start to see it's starting. You can see that it's starting to separate. So the bottom layer is the glycerol, and the top layer is the biodiesel. This is after leaving it for 2 days. You can see the biodiesel is a bit clearer, but there's still some parts of the glycerol in it. If we let it for, if we would have let it rest for longer, I think it would settle down. All right, so now that we separated the biodiesel, we took two pieces of cotton. We burnt one without biodiesel, and we put biodiesel on one and then burnt. So just guess which one is using biodiesel and which one is not.
The one with biodiesel will burn, right? Because diesel will catch fire.
It'll actually
What,
both will burn. Both will burn. It's just that the one with biodiesel will burn for sustained time. So it'll
Oh,
burn for longer. So like the one, as you guessed, the one on the right is the one with biodiesel.
okay.
Now, I'll be able to answer your question better about as to why we don't have biodiesel already. So,
Acha.
okay, so diesel is obtained from petroleum, and biodiesel comes from plants, seeds, and animal fats and oils. And diesel is non-renewable fuel, while biodiesel is renewable and decreases the usage of fossil fuels.
And another, we have two more points. So diesel, it emits high levels of soot and nitrogen, which creates which adds to air pollution. On the other hand, biodiesel, it has less emissions and it's better for the air and even improves the air quality, as we discussed before. And lastly, the most important point is that diesel is readily available. Diesel is readily available and it's cost efficient. On the other hand, biodiesel is not readily available and it's much more expensive because of the process through which it is obtained. So like this is one negative point of biodiesel, while so diesel gets one over it. So like the 3 points we discussed before this are all in the favor of biodiesel and why it's better, while the last one it's a disadvantage of biodiesel.
Adi had a question.
So what is soot? Third point of diesel.
So it's like this
Yeah, so Adi, soot is basically these solid particulate matter which are present along with smoke. So it's mostly
Oh.
unburnt carbon that is present in
Yeah.
the smoke,
Basically,
solid particulate matter.
Yeah. So sorry. So when you're cooking, and for example, if you have a chimney, you'll see that there's some black matter that accumulates over like the surface of the
Yeah,
chimney.
yeah, yeah.
Correct.
That is soot.
Yes.
So yeah, like I said, basically things
Okay.
that contribute to air pollution.
Okay.
Also, when we talk about fuel efficiency here, where we mean that it's going to be able to cover, for example, when we talk about fuel efficiency in terms of vehicles, using that fuel, that particular vehicle will be able to cover more kilometers,
More distance can be covered
yeah, per unit
in 1 liter.
of, yeah.
Okay.
All right. So, why can't we have functional biofuel yet? So, we've talked about the disadvantages of biofuel. So, do you think you'll be able to answer that, Ali?
Can you repeat the question? I couldn't get it.
I think so. We have talked about the disadvantages of biofuel,
Yeah.
and so do you think you have an answer as to why we can't have functional biofuel yet?
Yeah, because it is actually not quite cost efficient.
It's not. So another example. So biofuels. I mean, so the one we talked about, biodiesel, is an example of a biofuel. But there are other examples for biofuel, such as ethanol itself is a biofuel,
Oh.
and it's derived from corn. And the production of ethanol using corn, it has higher emissions than fossil fuels themselves, and it costs much more. So it's doing much more harm to the environment than fossil fuels themselves. So there's not really any point in extracting them unless the process becomes more refined and better and more cost efficient. Yeah.
So ethanol is type of a biofuel that is negative for the environment.
As of now, yeah, because its emissions are much higher when it's being
Then
created, and its
yeah.
costs are much higher.
Okay.
And again, with biodiesel, again, it's better than ethanol. It's still better, but again, the conversion from fats to the biodiesel is still like the process still needs work and it's still very expensive. And also, this biodiesel, when it's going to be used in cars, it's either only going to work in diesel engines or the engines will have to be modified in order to use it. So
Yeah, because
that's
engines aren't specialized for biodiesel now.
yeah, and they're specialized for their specific fuels. So we'll also need to have different kinds of engines than we already do.
Okay.
So like and yeah, so the three main points why we can't have it is like it's not cost efficient, like it requires a lot of spending and all, so infrastructure problem. Yeah, so these are the main 2 points. Why?
So that's it. That's all we have.
Yeah. Aditya, if you'd allow me, I can quickly share a little bit about the chemistry of, the chemical reaction that Aditya mentioned about transesterification. Since we have some time, we can utilize that to understand. Adi and Abhiveer, can we
Yeah.
discuss that? Yeah. Okay.
Yeah.
Sure. Okay. All right. Okay. So, right. So Aditya and Praneel explained to us how they carried out this experiment in the laboratory. They basically used vegetable oil and they added here in this particular chemical reaction, they write methanol. So it can be done with any of the alcohols. We did not have access to methanol in the lab, so we used ethanol. And then there is sodium hydroxide, which is NaOH, which is a catalyst that's used.
And we use potassium hydroxide instead of NaOH as well.
Yes, absolutely. Yes.
Okay.
We need the hydroxide and the OH is integral to us, so we can use any strong base there. Yeah.
Like
Okay.
potassium hydroxide would be stronger.
Yes, that too. Correct. All right. So, Abhivir, this might be slightly overwhelming for you, but will try to explain with as much clarity I can. So, if you look at this, the first chemical here is triglyceride, and which is largely what all oils are made up of. If you look here, I will just use it here. So if you look here, you have 3 carbon atoms, all the vertical lines representing a chemical bond. So 3 carbon atoms which are connected to each other, and each carbon atom is further linked to this group in a blue box. If you look at this, all 3 blue boxes are similar to each other. There's an oxygen, there's a carbon attached to an oxygen, and then there is an R group attached to the carbon. Now, this R group can be a long chain of other carbon atoms, right? So this is basically the structure of a triglyceride. Yes, Adi.
Ma'am, what is R? Because O is oxygen and C is carbon. What is
Yes.
R?
So R can be any long chain of carbon atoms. Yes,
Carbon
Praneel.
Okay,
chain.
it is not any element, right?
No. It's not a specific element. It's like, let's say it's a 2 carbon chain. So there will be 2 carbon atoms and 5 hydrogen atoms along with it. Or if it's a 3 carbon chain, then accordingly, like the number of hydrogens to balance that. Okay, so mostly these are very long chains which are present in oil. So let's say up to 16, 17 carbons as well. So those long chains, and they can be different from each other as well. Right? That's why R1, R2, R3. So we've put them differently. They can be the same, can also be different. Then when we add that to methanol, so methanol right now here, the reaction says methanol, we used ethanol. We'll just type the formula for. So if you look here, we used C2H5OH, which is ethanol, which has 2 carbon atoms, 5 hydrogen atoms, 1 group, and then you have an OH attachment, 1 oxygen, 1 hydrogen at the end. Then methanol is CHC. There's just 1 carbon atom, which is attached to the OH group. So now when NaOH is added as a catalyst, you get 2 different components. So I hope you remember the image Aditya showed to us. There was a separating funnel which had 2 layers, right? What were the colors that you saw? Just quick check.
Yeah, one was orange and one was dark red.
All right. So one was orange, one was dark red. Thank you for remembering. So the dark red color that you saw was actually glycerine, and that's the rightmost box here. It's a 3 carbon chain, right? And each carbon is attached to like a OH group, right? It's called a hydroxide group. So OH, OH, OH. That's how glycerine looks like. It's also the glycerine that you commonly would have used at home. Let's say you have mouth ulcers, you can apply glycerine. So this is that glycerine, okay, or for other purposes as well at home. So that's one of the products we got. And the second product is a mixture of fatty esters. Now this, if you notice, there is no carbon chain. These are like, these carbon atoms are not connected to one another. These are all separate chains, and that's essentially, this mixture is what is biodiesel for us. Okay, this is the fuel that burns to provide energy. So those are 2 products, and as Aditya I think mentioned in between, that we started off with some amount of oil, but we got 2 different components, and all of, like, the diesel is much less than the starting oil we got, which is roughly half. We haven't measured the volumes yet, but if you look at this, that we also obtain glycerine. What we're trying to do, we will, hopefully try to do it next week or the week after that, is that with the glycerine obtained, we'll try to make soap out of it. If you have the time, Adi, Abhivir, to reach out to Praneel.
I've actually made soap at home. I bought a science kit from Amazon and made soap.
Oh, great. So you know how to do it, right? So you
will there was some glycerine, solid glycerine, and then we made soap out of it.
Great. So there are other components that go into making soap along with glycerine. So that's why, so one of the ways in which, when biodiesel is made at a like on a larger level, they do end up using glycerine to create crude soap. Now that, I mean, of course, because there will be some other impurities in the glycerine as well, and purification would take another few steps. So that will not be possible in our current scope of the lab, but we'll try to do the best that we can just to see what comes out. And if you also like, just so basically when we compared vegetable oil and coconut oil for preparing biodiesel, just the R groups here in the starting triglyceride will be different. That will distinguish one oil from the other. So that's that about the chemical reaction that takes place behind what we did. And quick question, some of you would already know. Why do they separate in two different layers? Why do glycerine and biodiesel separate in two layers?
Ma'am, maybe because the difference in densities. So they form two different layers.
Great. Thank you, Adi, for sharing. And just for Abhivir, if we know density, it's great. Otherwise, you would know that oil and water don't mix with each other. If you have a glass of water, if you pour some oil on top of it, oil will remain floating on top. It will not mix at all with the water. Similarly here, these two components that we obtain are also distinct in densities, and hence we form two different layers. We open the separating funnel, we separate one component and we let the other one be, and then separate that later. So that's how this separation also takes place. Yeah, that's what I wanted to share regarding the theory of like the chemical reaction rate of trans-esterification. Yeah, because esters are formed, that's why it's called esterification. All right. So yes, any questions here? Anyone want to ask? Questions, thoughts, anything? Okay. All right. Okay. So that means either understood everything.
No, ma'am.
Yeah. All right. Great. Thank you. All right. So here, with this, we sort of close all the topics we had to discuss with you. Can you recall for us what are all the topics that we discussed across the sessions? What are different themes we picked up for green chemistry?
Last session was by Praneel and it was on essential oils.
All right.
The second session was on.
You watched that recording, Adi, and
Yeah.
you told me you watched it. What was that?
Forgetting.
Okay. What is this bottle made up of? I mean, this is not that, but then this is a hint. All right.
Bioplastic.
Thank you. All right. Bioplastic. And then today we did biodiesel.
Yeah.
So what I'll just play a video on which will just, just for us to sum up our understanding of the concept of green chemistry. So has anyone heard of systems thinking? Anyone can answer here.
I've heard of what?
Systems thinking. I'll put the word in the chat.
No.
Yeah. Any guesses on what you think this could mean? Systems thinking. Yes, Sandeep.
I can guess what it means. Maybe when like we allow technology to think. I mean, in that way, like system, like we say system. So AI based thinking, something like that.
Okay, he said AI-based thinking. Okay, how would artificial intelligence be thinking? Like if you said AI-based thinking, so if I have an artificial intelligence like a robot or something, what would they be? How would they analyze a situation? Like would it be very similar to human intelligence, or like how would it be different? If you want to share that.
Yeah, I think it will be different than human. How we perceive it, because we have a brain which can understand what's taking place, and an AI based software will have its own code where the way it's programmed. So he will look at certain things maybe from its features, which is the landmarks which it makes on a particular object.
Mhm.
It can understand what it actually is, based on the code, it can see what it is.
All right. Okay. So it has that limitation of, okay, well, if it's encoded in a particular for a particular task, that's what it performs. All right, great. So we are just around somewhere around, I mean, glad that you got the point of thinking clear. So we are thinking about something for sure. So we'll just watch a video. I will not share the definition of systems thinking yet. I hope my screen is like you can see the video. Yeah. Yes, just give me a thumbs up if you can see the video screen.
Yes, Praneel.
Yes, all right, okay. So yeah, so we'll try to understand, unpack. This is not a very long video, it's about 2.5 minutes. So we'll try to unpack what systems thinking is and how that's related to green chemistry. If you want me to pause at any point in the video, just let me know, I will do that. Yeah, just put it in the chat and I pause, or just come off mute.
Not sure what systems thinking is and what it has to do with green chemistry? Systems thinking asks you to look around and beyond the thing you're trying to make, to use a wider lens. Imagine you're making dinner for someone. You can focus on the end result and ignore everything else that went into making the dinner a reality. Or you can use a systems thinking approach to create a nourishing meal while respecting the health and safety of people and the environment. What do you need to make the meal? Are the ingredients locally sourced and sustainably produced? Did you create a lot of waste? Did you use a lot of energy? Was it a safe process? Is anything being recycled or reused, or can you make something else with it? Yes, healthy and safe food is important, but how the food is made, harvested, shipped, stored, what's done with the excess, and what it leaves behind are all important too. And it's the same process back in the lab. Green.
All right, just pause here. Any thoughts up to here? Thinking of what systems thinking could be? Like if you had just to define it in your own words. Yes, Adi and then Angad.
Maybe it is focusing on the process as well and not only on the end product.
Okay, focus on process, not just the product. All right. Yes, Angad.
Yes, ma'am. A similar answer, like to not just look at the final product, but also the history of where it started from and now what it is.
All right. Okay, fair. Thank you. Yes, Praneel, you want to add something to that?
Yes, ma'am. Almost similar answer. So, like, yeah, understanding the process and production procedure of various things instead of like the final end product.
Right. Great. Thank you for sharing. And it's also looking at a wider lens. So it's not like I want to create this. I don't care what all goes into making this. This is the product I want to create. I might turn the world around to obtain all the ingredients I need to create a product, but that's the product I want and that's the product I'll create. So that would be a very restricted view of things, as against a systems thinking approach where we look at all aspects of what goes into creating something, right? Or even if we look at it not just as a creation of a product, even if we look at a systems thinking approach to solving a problem, even then we are looking at, let's say, who are the people involved with this problem. Let's say I have, okay, well, that's very relatable. The ACs in school are not working, right? It's very easy for me to just right away shoot an email to the administrative team and tell them, okay, well, you're not working properly. The AC is not working. Rather than that, there is a wider lens because there are more people involved in the process than just the administrative team. It's also like perhaps the, well, the company that holds a contract for air conditioners at school, and if that servicing was done properly or not. So there is one, the company, and then there are service people who come regularly for their checks, and then there's the admin team, right? So for me to understand the depth of the problem, it's also important for me to understand who are the people involved here. So it can be both for the processes, for the people involved, all of that. So that's basically systems thinking. Let's see how green chemists utilize this approach to design better.
chemists focus on thoughtful design at every stage and consider all the inputs and outputs to the system.
Just hold this particular slide. It's like basically looking at the design, looking at manufacturing, looking at use and the end life, all aspects before planning to do an experiment.
Green chemistry concepts and practices give you, the chemist, the tools and knowledge to take a systems thinking approach to the design of chemicals, pathways, and processes. The result? More sustainable outcomes. Let's say you're working on a chemical that can be used to protect a crop. Say it's an herbicide, and you have one that works pretty well. You're done, right? Nope. A systems thinking and green chemistry approach starts before you begin your process. For example, have you thought about where your inputs are sourced? No, I mean, where are they from? Are they from sustainable sources? How efficient is your process? Have you avoided the formation of harmful byproducts? If not, have you identified and quantified them? Have you thought about managing exposure? What happens when you apply it? Is anything else affected? And does the material degrade? Does it persist or bioaccumulate? Once it's done its job, what happens to it? Can it be recycled or reclaimed? Let's start over using green chemistry principles and practices and using a systems thinking lens. How's the design? Beautiful. Byproducts or waste? Awesome. Efficiency? Energy? Nice. How about managing exposure and thinking about how material will degrade? Wow, impressive. Systems thinking gives you a lot more to think about. And by using green chemistry, the science is much more thoughtful and elegant in design. Great job.
All right. Okay. Any thoughts here? Anything that comes to your mind as we sort of watch that entire video? Yes, Angad, go ahead.
Yes, ma'am. So after seeing the video about like the latter part, I think I can very well relate it to the 12 principles of green chemistry about safer solvents and all those, the principles, because they're very similar to this systems thinking approach. And we should look at all the aspects about like where it is sourced from, what are the byproducts, degradation, etc., and not just the final product.
Great. Yes, thank you. Yes, Praneel, you want to go ahead, share something?
Yes, ma'am, similar thing. So like basically we saw like how green chemists use the process of the system thinking in order to reach the final end product and the goal. So like you first formulate like you make a hypothesis and all that. Then you also need to keep other factors in mind about so like the waste product produced, if it's eco-friendly, if it's cost effective, where you're getting your sources from. So all that.
Great. Thank you for sharing that, Praneel. All right. So the intention of this course was, I mean, this is not even, it's basically just a spark to green chemistry for you to understand that we know where we're headed as a planet, as a population, where we're headed to, right? If we can do a little better in terms of the resources we use, the kind of waste we're generating, that will go a long way in trying to preserve what we have right now. Hence, this was a spark to understanding green chemistry a little better. The few experiments that we did carry out were again, and just to initiate thinking that these can be done and it's very much possible in our scope as well.
And
The understanding of
now
this is
that we learned like about the principles and everything, we can look at other problems that exist, like for example some other materials or anything that are causing harm, and we can apply these principles and think of solutions on our own as to what we can swap out certain materials and apply the principles and help the environment so that we have better future.
Thank you, Aditya. And also being more mindful and thoughtful even while you are in the laboratory. Now that we are back in physical school, you will be accessing the laboratory a lot more. So what is the kind of waste we are generating even while we are doing our everyday analysis or just carrying out a simple chemical reaction, being more mindful of, okay, well, what is the product created here? And if I throw it right in the sink, where is it going to land and what problems can it cause? Because right now we're thinking of one test tube, perhaps 2 ml of the waste we generated going into the sink. Imagine that across laboratories, and not just at this scale, at very high levels as well. So being more mindful of how we carry out procedures, how we use chemicals, where are the chemicals that we're using in the lab, where are they sourced from, and where are they going? So that was the intention of this course. And I hope you really had some insights while all of us were presenting to you. Adi, Abhivir, would you have any feedback for us? And anything that you like, if you could
It
use
was
it.
a nice session, but why did it last like shorter than the last 3 months?
This is shorter because we didn't do the experiment here. Otherwise, we would have, let's say, about 10-15 minutes would have gone into performing it.
Yeah,
We
So
were
I
sure
was
ethanol and
expecting,
NaOH.
there was no experiment this one.
yeah, also I was expecting many more people and thought it would be much more interactive. So that was,
Yeah, that's
So
also
can we
one.
make the biodiesel in classes in schools?
Please. In fact, since we've already made it, come and make soap with us. That would be also helpful. But what we can do is right now, we can try biodiesel for different types of oils that we have at home.
Yeah.
So that
like
would also be a
if
good exercise.
so like if anything like is cooked at your place with using oil, like any kind of oil, like you could we could try it with olive oil maybe, used olive oil or even used vegetable oil, since we used unused
Palm
vegetable
oil
oil.
as well.
You could bring it to school and we could try using that.
Yes. Yeah. Of
What
course.
about palm oil?
Yeah, we could use that as well. And also like
Any natural
sunflower oil or something, and mustard oil. Like we can we can like have a comparative analysis, and that could be a project that you could do as a group with each other and see the results that you obtain. Yeah.
And essential oils?
Essential oils, again, distillation is a process we could carry out, but we couldn't do the liquid carbon dioxide extraction. So that's something that we will work on again. So
No.
if you,
I'm saying, can we use essential oils in the process of making biodiesel
how
instead
would
of
you
actually
use that?
sunflower oil and all that, they'll contain essential oils.
Yes, yeah. But so
Okay,
one thing we
so
can use the essential oils for is, let's say, again, I'm coming to soap again and again. When we do if we do end up making the soap from the glycerine obtained, we can use
yeah,
essential oils to scent the soap. So that's how we can actually be using, extracting it from one source and putting it in another source. That will also give you a lot more perspective on how a more complex process is taking place.
yeah, there I put some scent in my soap as well.
Yeah. Oh, yes. Right. So here we could use the scent that's naturally sourced. So why not? We can go ahead and do that as well. Yeah.
Okay, ma'am.
Yeah. Abhivi, do you want to share any feedback for us? Anything that you like what did you like the most through the sessions? Anything that you want to share? Hi, Abhivi, are you here? Okay.
Yeah, ma'am, are you talking about like all the sessions or just
Yeah.
this one?
This one, or in fact, I'm talking about all, anything that we sparked in you and you would want to continue doing.
Yeah, so I really like the experiments we did, like making the bioplastic, and also I don't remember what we had done in the last class. I think we had done
Essential
something
oils?
with dry ice.
Yes, right. We were trying to extract the essential oil of from orange.
Yeah.
Yes, right. So you like the experiments a lot.
Yes.
So please join us in the lab sometime and try them out with us. Any of us you can, yeah.
Okay, ma'am.
Right. Okay. So great. That's all we wanted to share with you. I will also be dropping a feedback form in with the concluding email. So if you want to, it would be a good idea for us to have that feedback recorded. And thank you for reminding me, Angad. We will be handing out the certificates soon to those who attended all sessions. All sessions meaning like Adi and Abhivir have been around for 3 at least. So, and even others who have been around for 3 or 4 sessions. Yes, so you will be receiving them soon. Yes. So thank you for your time. And let's not just leave it as something that we attended once. Let's take it forward also from here and reach out to each other and try out things in the lab that we can. Yes.
So which day, ma'am?
Which day? Well, Wednesdays are usually
Wednesday is usually very
usually
non-busy.
light for us, so you can, and even for teachers, so you can actually reach out on those days. Even other days, if you have a free class, you can just connect. And even there is Sandeep sir in the lab, in the chemistry lab. So he's helped us with all the practicals that we did. So he will also be able to assist you in case we are not around, any of us are not around.
We can decide the timings and all in school itself, but just tell one of us beforehand about like what you want to do at school so that we're prepared.
Yes, absolutely. So if you know that you want to try out a particular experiment on the next day and you have a free slot, just let us know a day in advance, that, or a couple of days in fact. So just for us to arrange everything beforehand.
Okay, ma'am.
Yes. Great. Thank you so much, everyone.
Thank you, ma'am. Bye, ma'am.